Ever stop to think about what's actually going on when you, say, take a walk, or jump, or even just lift your arm? I mean, really think about it. Well, every single move you make is this incredible masterpiece of physics and biology. It's like a hidden choreography that's happening every second of every day. And today, we're going to pull back that curtain.
So, let's just dive right in. Take a look at this runner. It looks so simple, right? So natural. But underneath it all, every single stride is a symphony of forces and levers and angles. It's a performance, really. And the science that lets us understand that intricate choreography, well, that's what we're going to explore today.
You can think of this whole explainer as kind of a peek into the user manual for your own body. We're going to break down the fundamental principles that govern how you move and hopefully turn some really complex science into something you can actually see and understand.
Now, the big picture here starts with a field called kinesiology. That literally means the study of movement. It's this huge umbrella, covering everything from exercise physiology all the way to sports psychology. But today, we're going to zoom in on one of its most critical, most fascinating branches.
And that branch is biomechanics. This is where biology gets to shake hands with the laws of mechanics. We're talking about the physics of life itself, how forces act on and, more importantly, within our bodies, to create, control, and perfect every single motion we make.
So here's where it gets really cool. To actually make sense of all this, we split movement into two totally distinct parts. First, there's kinematics, which is all about describing the what of motion. And then there's kinetics, which explains the why. And yeah, we're going to tackle them one by one.
Okay, so first up, kinematics. I want you to think of this as being a detective of motion. We are purely focusing on describing what we can see, the path, the speed, the timing, without worrying about the forces that make it all happen, at least not yet.
So the really crucial point here is that kinematics is just the geometry of motion. Think about a physical therapist who's measuring how far a patient can move their shoulder. They're not measuring muscle force, right? They're just looking at the angle, the direction. That right there, that's pure kinematics in action.
And movement basically breaks down into two fundamental types. On one side, you've got linear motion. That's the body moving along a straight line. And on the other, you have angular motion, rotation around an axis. Now here's the amazing part. Almost everything we do, every single action, is some kind of sophisticated blend of both of these.
Let's actually put a name to all those big, visible movements we see. That's called osteokinematics. This is literally the movement of your bones in space, like when you bend your elbow or raise your leg. It's the voluntary, observable stuff that we all think of as action or exercise.
But that visible movement is really only half the story. To truly get what's going on, we have to go deeper. We need to dive into the secret, kind of invisible world that's happening inside our joints with every single move we make.
Which, of course, brings us to the key question. When you bend your knee or you shrug your shoulders, what is actually going on at the surfaces of the bones, right where they meet each other?
And the answer is something called arthrokinematics. It turns out your joint surfaces aren't simple hinges at all. They perform these tiny, involuntary, but absolutely essential micro-movements. A little roll, a glide, maybe a spin. Seriously, without this tiny, intricate dance, our joints would just jam up and lock.
And check this out. This is so cool. There's this beautiful, simple rule that governs this whole dance. When a convex or rounded surface moves on a concave one, think about your shoulder. The roll and the glide happen in opposite directions to keep the joint perfectly centered. But when a concave surface moves on a convex one, like your knee, they move in the same direction. This elegant little principle is absolutely fundamental to joint health.
So let's put it all together. On one hand, you have osteokinematics. That's the big, voluntary, visible movement of the bones. And on the other hand, you have arthrokinematics, the tiny, involuntary, invisible dance of the joint surfaces. And you absolutely cannot have one without the other for proper healthy function.
All right, we have totally nailed the what. Now it's time to get to the why. Let's shift gears and dive into the world of kinetics, which is the study of the forces that are the true engines of all our motion.
Kinetics is all about the pushes and the pulls. We're talking about the force your muscles generate, the constant downward pull of gravity, and any external load you can think of, whether it's a dumbbell you're lifting or just the ground pushing back up at your feet when you run.
At its most basic level, a force is just a push or a pull. That's it. It's the agent of change. It's what causes things to start moving or stop moving or change direction. And in the world of physics, we measure that in a unit called the Newton.
And here it is, the classic equation you probably remember from science class, Newton's second law.
Force equals mass times acceleration. It's the simple but incredibly powerful heart of kinetics. It just tells us that to move a heavier object or to make any object speed up faster, you just have to apply more force. It's the why of movement, all captured in one elegant little formula.
Okay, so this is all fascinating theory, but what's the payoff, right? Why does any of this matter? Well, let's connect all these ideas to the real world and see how biomechanics gets put to work every single day, especially in places like physical therapy.
This is a perfect practical example. After something like a knee surgery, a therapist's entire plan is basically pure biomechanics. They'll probably start you with open chain exercises, like leg extensions, where your foot is just free in the air. That lets them safely isolate and strengthen the quad. Then, as you get stronger, they'll progress you to closed chain exercises like squats, where your foot is planted on the ground, to rebuild functional strength that actually mimics real life.
So let's bring it all home. Understanding the big bone movements, that's osteokinematics, helps us analyze how we function. Knowing the tiny joint movements, arthrokinematics, lets a therapist pinpoint the real source of a problem. And kinetics? Well, that explains why the movement is happening the way it is. You need all of these pieces for a healthy, stable, and pain-free body.
And that brings us to the end of our deep dive. The final thought I really want to leave you with is this question. Now that you've had a glimpse of the hidden choreography happening inside your own body, how are you going to see your own movement differently?